Hello, my name is Samuel Breslin. Again, I'm the Solar Gators Electrical Integration Lead. This is the second video in the Solar Gators integration series. Today we're going to start designing the Solar Gators integration board in Altium. So this is really fun. It's going to be a really good project for all of you guys to learn Altium. So first I'm going to show you the board that we're going to be designing, go over it high level, and then we're going to start, I'm going to start walking you through the design of it, and hopefully you all can follow along. So like I said, we're going to have Altium open. I'm going to go ahead and open the project that I already have, mostly completed, that you guys are going to be replicating and changing up a little bit. Okay, so we're going to start with a 3D view of the PCB that is the Solar Gators integration board. And you can see it's a pretty small board, not too many components on it. If it looks overwhelming now, don't worry, I'm going to do a very deep dive over the course of the next few videos into how we chose every single part for this board. I'm going to try and be as thorough as possible. But essentially, this board has a few features. It is powered over here with a 2-pin male header. Can communicate over CAN bus with the CAN header over here. It is another 2-pin male header. Like I said, this is just the Solar Gators integration board. We use some very different parts on the actual car, but we are just trying to teach you how to design things. We would never use these 2-pin headers for a CAN bus connector. So it can communicate over CAN bus. It has the programming header up here. This is the STM32, the main microcontroller controlling everything. This is the TI CAN chip. This is a AMS voltage regulator. This is a inertial measurement unit. Like I said, if you don't know what any of these parts are, we're going to explain all of them. This is a header that will allow you to access the I2C bus. This is a header that will allow you to access a UART bus. This is the clock, and then there's lots of other little lights and passive components all over the board. But yeah, now we're going to go into the schematic and look at some of these parts in a little bit more detail. Okay, so up here in the top right corner, we have the power section of the board. So as you can see, the power comes in here through this component. It is filtered by this little pi filter. So pi filters act as low pass filters, which means they let through lower frequencies, and higher frequencies are filtered out. So this allows us to filter out high frequency noise in our power lines. So the 3 components which make up this pi filter are 2 2.2 microfarad capacitors and 1 farad bead. Then this is the voltage regulator that I described, the AMS 1117 3.3. So it has the voltage input pin, which I believe can go up to around 12 volts, and the voltage output pins, which is a fixed output of 3.3 volts, as well as our ground pin. These ground flags here essentially indicate to Altium that when you go to draw up the schematic for the board and the actual physical connections, all nodes with this ground flag should be connected to each other. So just so you guys know what that is. Same thing with this V-bus and 3.3 volts flags up here. So once the voltage regulator is spitting out 3.3 volts, we have a bulk decoupling capacitor here. And again, a 2.2 microfarad capacitor and a little LED or light emitting diode. So this LED has a 1 kilo ohm resistor in front of it. We're going to go into a little bit why we chose that resistor later on. If we go down here, we have the 2 schematic symbols which make up the microcontroller. Like I said, the microcontroller is split into 2 schematic symbols, although it is one part. Sorry, I forgot to plug in my laptop. Although it is one part. So this is the power section of the microcontroller. As we can see, we have these VDD, which are our voltage input pins, and our VSS pins over here, which are our ground pin. We also have a backup VBAT pin, we're just going to connect that along with all the rest of our VDD pins. We also have a reset pin and a boot 0 pin. I meant to make a slight change to this, but we'll go over that when we do our designs. Um, this is again, the microcontroller section. So we have a bunch more of those flags. As I said, when we go to route it, Altium is going to know that I want this PA9 pin to be connected to this third pin on this header. That's what those flags mean. Using these flags just allows us to make our Altium schematic look a little nicer, as opposed to sorry about that. As opposed to running all of these wires across the board. Sorry, my Altium is acting up a little bit. Okay, so we also have our I squared C lines. Our I squared C lines are tied to the 3.3 volts line with these 2 kilo ohm resistors. Again, we'll go into why that is a little later. We have our oscillator in and oscillator out pins tied to our clock over here. The clock output pins and input pins are tied to these 10 picofarad capacitors, which are tied to ground. We have our CAN chip. So we're going to go into the CAN network, or sorry, CAN sensor controller area network. We're going to go into CAN bus architecture a little more deeply, but essentially, the most important part is CAN is a differential pair, as indicated by this little symbol. And this CAN chip is responsible for taking the simple CAN TX and RX, which are sort of standard ones and zeros that you would see in a microcontroller, and creating a differential pair out of those. The differential pair, when running through a twisted pair of wires, which a twisted pair means the wires are physically twisted around each other, helps with the signal integrity in the car. So right here, so that is our CAN section. We have some LED outputs. Again, these are tied over to our microcontroller through a resistor to the diode, the right side of which is tied to ground. We have an STM OK status light. We have some headers. So here's our programming header, the UART header that I talked about, the I2C header, and the last interesting part of the board is this inertial measurement unit. So this measures things like acceleration in all 3 axes. And obviously we have different parts of it tied to 5 volts, ground, a couple flags, and these little X's are no connect flags. So telling Altium that we don't want these pins to be connected to anything. Again, we're going to go into how we chose all of these capacitors, why we have these certain flags, and we're going to go all into that as quite deeply as we design the board. But yeah, go ahead and watch the next video for information where we go through how to design this power section of the board up here. But yeah, thank you.